back. This is sort of an extension of the previous compound. The mechanism is almost the same, except we have to make slight modifications. So before we get started, what I have done here is I have taken this compound, which is our primary reactant, and drew it here, explaining the various components of it. Now, if you remember, if a bond is just on the terminal end, it's got to be methyl, right? So we have 3 hydrogens here on this carbon. Okay, this is the carbon containing the leaving group, which is the OH, and that's got to be the alpha. The carbons adjacent on either side is the beta, right? Now, if you were to proceed with this reaction, which we are going to, so the first thing is, you get a different color. So we are going to add sulfuric acid, right? Let me get a different color. Okay. So what's the first step is you're going to protonate this compound with containing the OH, right? So I'm going to just draw everything in black except the OH2+. So I'm going to draw that in a different color. Actually, I might step back and draw the benzene ring a little better. It looks kind of crazy. So, all right. So, all right. I'm drawing the benzene ring just one more time. Hopefully it's better. Yeah, it's better this time. All right. Now, our first job is to protonate the OH. So that will be the same. There is no difference in that. So we've added a H to the OH, so we've got plus charge now, right? This is exactly what we did in the previous case. Of course, what I did is, your HSO4, and this is going to abstract the hydrogen, and then this comes off, right? So you have this plus HSO4 minus. Now, the reason I find this problem interesting is there's a lot of room for instruction here. Now the OH2 comes off, okay, which is what, so again, we're still not deviating from what we did. So the OH2 is going to come off. So the first 2 steps are exactly the same. There's no difference, okay? Okay. Now what happens? Well, technically you could do 2 things, okay? You could remove this hydrogen, okay? Right? You could remove this hydrogen, right? And this bond could come here, right? And then you can have this as product. Because keep in mind, we even took a quiz question which said it's always the beta hydrogen that comes off, right? So let me redraw that a little bit better. Okay. If you chose to remove this beta hydrogen, this is the product. Let's say if you chose to remove this beta hydrogen, which is this hydrogen, okay, I'm going to write that in a different color. So this would have been the product if you had done this, okay? Let's say if you chose to remove this hydrogen, which is this, if you had chose to remove this one, then this bond would have come here and neutralized the positive charge, which in that case would have given you this as a product. Okay, there's also one more that's possible, which is neither of this is major. Okay, these are both minor products, but among these 2, this is the major, this is the minor, so this is subminor, minor, and then what we are really interested in is, let's redraw this. What's going to happen here is I am going to rewrite this one more time. The initial product that we had, I'm going to redraw this, okay? Right? We have this hydrogen, right? We could have a hydride shift. So this hydrogen could come here and the positive charge could go here, which means now we have The positive charge is here, and the hydrogen has come here. Okay, now you have two options. You could remove this hydrogen, which would be same as this product. Okay, so we're not going to do that. So now we have two options. We can remove, I'm going to draw this in again a different color. With respect to the positive charge, you can remove this hydrogen or this hydrogen. Okay, so in that case, if you chose to remove this hydrogen, let's say HSO4 minus comes and remove this hydrogen, this bond comes over here, neutralizes the positive charge, and gives you this as product. Or, I'm going to draw this in a different color. The HSO4 minus could come, grab this hydrogen, and move this bond here, which in this case, okay, let me redraw that for a second. Okay, anyway, so it could come here. Okay, in that case, you will have this as product. Okay, now we have essentially got four products. Why do you think this is a much more favored? Why do you think we need to hydride shift to get here? Why is this required? What is the big deal? Why do you need to do the hydride shift? Because remember this, I'm going to make a box and write underneath it, because that's the information I want to drive. Is something we have already learned is tertiary carbocation is more stable than secondary carbocation, which is more stable than primary carbocation. What we initially generated, which is this and this, they're both secondary carbocation. Okay, carbon at least contains one hydrogen, two other bonds, and a positive charge. But this structure right here, this is a tertiary carbocation, because carbon contains three bonds and a positive charge with no hydrogen. That's more stable. So whenever you have a stable carbocation, the product that comes out of it are even more stable. So which one do you think is most major of this four? Well, these two are in a way identical. So, they're identical. So it's major because they have come out of a tertiary carbocation. Essentially, Zaid's a rule. The more centered the double bond is, well, more stable it is. Compared to these two, the bond is more inside. And then out of these two, this is the second major product. And this would be the minor product. Does that make sense? I mean, I expect you to go through this video. You can't just process all of this in just watching one time and get it right, right? Now, here's your practice, okay? All right, so I'm going to write the products. You're welcome to pause the video at this point and then I'm going to write all different products possible. You can pause the video, continue watching to see if you got the product right, okay? This is your time for you to practice, okay? I'm only going to write the products, and it's your job to actually figure out the mechanism, which I might test you in class, okay? All right, so these are the products possible. You could continue moving it, but it's, if you can do at least one tertiary carbocation and get the product out of it, that's pretty good. So these are the three products possible. There's one more that's possible, but it's going to be same as this one. Okay, it's going to be very much similar to this one. Or I guess you can keep going, but if you got this far, it means if you got these three right, that means you already know the material. So I don't want to go too far into it. This is good enough. And based on our idea of Zaitsev rule, I would say that, you know, which one is more stable? Well, this is kind of more centered, so this would be the major product. This would be the second major product, and this would be the minor product. All right, that's for you to practice. And this concludes the three electrophilic reactions that I want to get across to you. And then we're going to look at additional materials as we go on. All right, so stay tuned.